1, 2, 4. So it turns out if you, so we're below the threshold here.
So maybe 4, because it's half of the last successful one.
I'm pretty sure it's half of the last one, whether it's successful. Actually, I'll have to.
Ceiling.
I think it's round. I think it's actually round. I'd have to check. That's a technical issue. That's not really a big deal. Okay. 1, 2, 4. Okay. The threshold is 5. If I double 4, I get 8, which is more than 5, so I just go straight to the threshold. Next is 5. Next one after that, 6. 1. 7, that's 2. 8, that's 3. So how many packets in the buffer so far? 6. 4, 9. Any comments at this point? I think it's dropped. What is my new congestion threshold? Because it depends on whether you do ceiling or round or what. If you do round, it's 5. It actually doesn't matter if you do 4 or 5 because the jump, if I started with 4 over here, I would still go 1, 2, 4, 5, 6, 7. So it actually makes no difference.
So we never jump to 8. Like we always check the threshold and not. So we always do 1, 2, 4, 5.
Yeah, you always check the threshold first. That's right. But what you'll notice is that my threshold stayed the same. So next time I do this, I'll get the same behavior. Actually, and as I pointed out a second ago, you can check on your own. If I had a congestion threshold of 4, I would also get the same behavior. So it doesn't matter if I do the round or not. So this is the steady state. Okay, steady state behavior. So in other words, if I keep transmitting packets, how many packets get through? 1 plus 2 plus 4 plus 5 plus 6 plus 7 plus 8. Throughput in packets. 1 plus 2 plus 4 plus 5 plus 6 plus 7 plus 8. Heard a lot of random numbers being shown. 33 segments. 33 segments. How many round trip times? 1, 2, 3, 4, 5, 6, 7, 8 round trip times. So I count this one where it was dropped because basically this is periodic. So every 8 round trip times, I can send 33 segments. So I get 33 over 8, which is 4.125 segments per round trip time. What is the maximum number of segments I can get through? 35? In 8. 40. So the rate limiting feature of this channel is the fact that the wireless link has a capacity of 5 segments. So in other words, using indirect TCP, I can send 4.125 segments per round trip time, and the absolute maximum I can possibly get is 5. So that's not bad. I'm getting more than 80% of the capacity of this link. Question?
The n value of n you chose arbitrary, right?
Yes. Yeah.
We can choose it in such a way that it's optimized for at least 35 instead of 30.
You probably could. So as I said a second ago, I chose n specifically because I wanted to avoid the problem where, like basically these packets that are stuck in the buffer have to get transmitted over here.
Exactly.
So if there's not enough space in here, then those packets would start accumulating, and then I'd have a whole new problem. So I wanted to avoid that, so I picked N specifically to avoid that.
But in our steady state, the excess packets that we have are less than the space that you have now.
That's true. So I guess I could have been a little more clever with that. You're right. But anyway, my only point here is that that's not too bad. You can do better than that, but not hugely better. Okay. Now let's look at an example where we have similar analysis, but okay, example 2. Similar setup, but after slow start.
Sir,
Yes.
is it just a coincidence that the steady state occurred threshold with the K?
Well, as I mentioned, it could have occurred with threshold at 4. If this had been 4, that would have also worked. I guess the broader question is if is it necessary for the threshold to be less than?
Depends on the buffer size.
Yeah, it depends on the buffer size. That's true.
So if you have a really big buffer, it doesn't matter what your K is.
Yeah.
You're still going to be acknowledging your threshold will be way further.
The buffer depends on the slow start.
No, buffer is a buffer size.
I mean, in my simplification here, yeah, the buffer is dependent on the length of slow start. That's a good question. I actually don't know.
Buffer could be receiving many nuts.
I guess. So, I mean, everything we've done here is to boil it down, boil the big, huge problem down into something that we can look at and sort of understand. So,
Again, it's going to depend on your K plus your N, not on one
not on one or the other.
Because we just assume that we have a link that deals with K plus N.
Probably true, but there's something compelling about this idea that I mean, 5 is kind of the capacity, and it seems like your window might have to be less than that. Although I'm not willing to say absolutely for sure. Like I suspect the counterexample, you might be able to construct a counterexample with where the threshold is 6. Like probably it can't significantly deviate from K, but I wouldn't be surprised if you could find a counterexample where it's more, but just like 1 or 2 more.